Okay, so we're going to get our first chance here to solve a problem using Newton's second law. Okay, so example 3.3.1 says a 2.2 kilogram object has an applied force of 32 newtons right and a force of friction of 14 newtons left. It wants us to A, determine the net force acting on the object, and then B, calculate the acceleration. Okay, so remember, like I said, get in the habit of drawing yourself a free body diagram to give yourself the given information within the problem. So it's going to come into effect here, like I said, why I draw our free body diagrams with a box, because now that we're given a mass, we can place that mass of the object right here in the middle, and therefore that piece of given information is now in our free body diagram. Okay, now it gives us an applied force and a force of friction here. So what that means is the object, or we can assume that the object is traveling along a horizontal surface. So with any object on Earth, we know that there is a force of gravity that wants to pull us down towards the center of the Earth. Okay, and if it doesn't say anything about motion in that direction, then we can most likely assume that because of this force of friction, we're on a horizontal surface, which means that there is a perpendicular force to that surface that is going to be equal in magnitude but opposite that force of gravity, that allows us to have an F net of 0 in that direction. Okay, so we can assume that and add that into our free body diagrams, but we know those aren't going to factor into our calculation. Okay, we can then look at the other forces that are involved. We're given that there is an applied force of 32 newtons acting in this right direction, and a force of friction of 14 newtons that acts left. Okay, so now that we have our free body diagram with all our given information on there, we can go and determine the net force. Okay, I'm going to use our right direction as positive here when defining the directions for our forces. So when we go and solve for what F net is, we're looking at the forces that are involved. We know the force of normal and force of gravity are going to cancel out, so we don't have to worry about them. Okay, so the net force is going to be in this horizontal direction. What two forces act in that direction? Well, we have the applied force that acts in the same direction, or as what we said is going to be positive. So FA goes in as a positive force, and with that force of friction acts left, so we're subtracting the force of friction. Okay, so F net is equal to 32 newtons, subtract 14 newtons, which gives me a total of 18 newtons. And remember, because you defined your direction here as positive and negative, because this force comes out positive, it tells us the direction of F net. So therefore, the net force acting on this object is, if we consider our two significant figures, our mass had two. I know we haven't used that yet, but the two forces that we've been given also had two significant figures, so we don't really have to worry about rounding. So the net force is 18 newtons, and because it came out positive, we know that that net force is acting to the right. Okay. Now, from looking at Newton's second law, we know that any F net will cause an acceleration on an object in the same direction as that net force. Okay, so to solve for the acceleration, if we know that net force acting on the object, all we need to know is the mass and acceleration of that object, and that is another way to determine it. So now that we know the net force and we know the mass, we can solve for what the acceleration of the object is by dividing both sides of my equation by mass. So that means the acceleration of the object is going to be equal to the net force divided by the mass of the object. Okay, the net force was 18 newtons to the right, and our mass was 2.2 kilograms. Okay, so remember, when you're dividing a vector quantity by a scalar quantity, that doesn't do anything to the direction. Much when we divided like velocity by time to get acceleration, it doesn't change the direction of that vector quantity that you're dividing by. Okay, so that direction of our acceleration is going to be in the same direction of that net force, which is to the right. Okay, then when you divide 18 by 2.2, I get an acceleration of 8.1818, repeating, meters per second squared. Okay, and for a little bit of unit analysis, remember the way that works out is a newton is equal to a kilogram times a meters per second squared. So if I have a newton divided by a kilogram, that means I have a kilogram times a meters per second squared divided by a kilogram, which cancels your kilograms and leaves you with only meters per second squared. Okay, and then remember that direction is going to remain the same. So all that's left is to put the acceleration into significant figures. Remember, we already determined that was 2. So therefore, the acceleration of the object is 8.2 meters per second squared in the same direction as that net force to the right. Okay, and that's a basic look of you at using Newton's second law to determine net force and thus the acceleration of an object. Okay, this is Wanny signing off, and may the force be with you.